Okay, today I am putting a video up about abstract classes. So an abstract class is a class to keep everyone on the same page. So in this example, my abstract class, and it's denoted by the word abstract here, is called shape. Now, as you know, there are a lot of shapes out there with all different names, but they all have a name. So in the abstract class, I allow it to have a name. But you know that computing the area and the perimeter of them may not work. Like I can, if I have a square, it's the side squared. If I have a circle, it's pi r squared. So there are a lot of different ways to create the area, and it would be silly to make one that that all of them fall into. Okay, hexagons, all those have different areas and perimeters. Semi-perimeter we can define as 2, as per the perimeter divided by 2. That's okay. So with this one, an abstract class gives some of the ways that we want to have this object act. So they all have some similar characteristics, so they all have as a name, and they all have their perimeter. Semi-perimeter is their perimeter divided by 2. But when we find their area and their perimeter, it's different for both of them, for other objects out there, or shapes. So that's what an abstract class is. An abstract class has at least one method not implemented. Okay, and when we don't have implementation for it, we do put abstract. So if you have just one abstract method where you don't have actual code for it, then it automatically needs to be an abstract class. The moment we have an abstract class, we still need a constructor like I have here, but we cannot create an object of this type. Cannot, and I'm going to use the word construct. So you can't instantiate an abstract class. Okay, so we can't instantiate it. So that means I can't go out and create an object of this type. Okay, it's really just to keep everyone having the same characteristics. So if I have a shape, everyone's going to have a name. Everyone will be able to find the area. Everyone will be able to find the perimeter. I just don't know what that is just yet. So we create a subclass using the words extends of an abstract class. So this is different than an interface. So use to basically to implement an abstract class. Okay, and maybe implement's a bad word here, so let me just say use an abstract class. So here I can create a constructor, and it does use all of the methods that I created here. So semi-perimeter and getName will exist, and I need this because it is technically a subclass. I cannot make an object of that type, but a subclass can construct objects of that. You know, it can use methods in that class. So it does call the superconstructor, and notice I'm calling one with a parameter. And now this is a square. So if I want to find the perimeter of a square, I do something. And if I want to find the area, I do something. So this is specific to the square, but it still has the characteristics of a shape. So it still is has a name and etc. So a circle does other things. So a circle, I can create a constructor. I can create objects of that type, but its perimeter and area are different. So, but it still has an area and a perimeter, and that's the basic idea. So if I try to create, let's say, a circle, but I don't actually create the area, let's say this one doesn't actually exist. Okay, that is a problem. So it says circle is not abstract. Okay, so if it was also abstract, then I could have not. So if I actually put abstract here, this wouldn't be an error. Okay, because one of the methods is not instantiate, like it's not implemented. Okay, the area one that doesn't have code over here must be implemented in its subclasses, or it itself is an abstract class. And if you want to actually create objects of type circle, that's silly because you need to be able to create an object of that kind. So I must, every time they're in an abstract class, if there isn't a method with, if there are abstract methods, ones that don't have implementation, then I need to give it code. Okay, you can tell the ones that don't have implementation here. They have a semicolon right after the header. So it gives the name, it would give parameters if it had it, and it would give the return type and also public. And then that's it, just a semicolon and you're done. Curly brackets would be bad, you'd put the semicolon, done. So if I wanted to implement this with the tester, what you're going to wind up having is, sorry, I don't know why it won't let me fix it when I'm not on video. So if I try to create an object of type shape, it has an issue. So if I run this guy, I can reference it here, but I can't construct it. This is illegal because you can never create an object of the type of an abstract class. However, I can construct it with one of its subclasses. So referencing it is fine here, but if I construct it, it has to be a concrete class, we call it, a class that all of the methods have been implemented. So in this particular case, I have two shapes, a circle and a square, and I create them as a circle and a square. So they have the reference of the abstract class, and here I have the subclasses. So here, these are almost exactly the same. Right now it's just null. So if I run this, what happens is if person enters circle, then this shape becomes a circle. If they enter anything else, the shape becomes a square. And I can get the name and it references that name, the correct name and the correct class, and the area is done correctly. Okay? Because remember, when it runs it of the type that it was constructed. It won't try to run the shape. And this is one of the reasons why that is the case. So if I didn't believe in this and I didn't want to put shape and I tried to put circle here, problems would occur. Oh, was there a problem? Sorry. Yeah, already I wanted it to be this is a compile problem. So I am trying, if I have a circle, it won't allow this. Okay, because it's just not the right type, because these two start out as shapes and that's a circle. So maybe if I change this to circle, now they would be the same type, but this one isn't. So how would I I can't change this one and that one. So I compromise and I'm like, okay, well, they're all shapes, so let's keep them shapes. Okay, but when they're constructed, make them their proper shape, a circle or a square. Okay, so that's an abstract class. Remember, all the methods that aren't implemented in an abstract class need to be implemented in the subclass. All right, have a good day.